Richard James will present Transposition Tutorial 1. Transposition is a process by which we change the subject of a formula or give a formula a specified subject when it does not have one. There is a wide variety of approaches that we may take in transposing a formula. I am sure that by the time that we are through with these tutorials, we would have taken a look at the most popular ones. We surely may not take a look at all, because the possibilities are endless. We will not mention any of them in these introductory remarks, because that would amount to no less than an entire instructional video. We will go straight ahead with the explanation of the steps involved in transposing each formula. We will place a bar between the two steps for which we are discussing the intermediate step. For example, if we are discussing the intermediate step between these two steps, that is, we are showing the process that we have to go through, or a likely process that we have to go through or we may go through in order to get from this expression to this one, then we will have a red bar showing that we are actually going from here to here. Also, if we are going from here to here, then the red bar will be here showing that the step that we would normally call hidden, because it is not present in this script, that the hidden step is actually the step that will take us from this expression to this one. As a matter of fact, if we should include all of the intermediate steps in a transposition formula on the examination, then we will find that just for the transposition problem, which may just be a small part of an entire problem, that transposition problem will have the potential to take up the entire page when it is not necessary. Also, it will accumulate a lot of time just writing those steps. However, in order to make the process of transposition very clear, for the purpose of this video presentation, I will include those intermediate steps in the explanation beside the script. And as a matter of fact, we will use the red bar to our advantage as an indicator showing that the process that we have on the right hand side is the one that should take us from one expression to the other, and that will be indicated by that red bar. I am sure that we have a wide enough variety of problems to demonstrate the fundamental principles involved in transposition, to the extent that, left on your own, you will be able to pretty much transpose any formula with which you may encounter. One of the earliest principles is eliminate the letter, symbol, or operation that is least related to the proposed subject in every step, and that we will not only demonstrate but we will continue to explain throughout these tutorials. Eliminate the one that is least related to the proposed subject first. Here we intend to make P the subject of the formula. Accompanying P, we have S, 4, 3, we have the square root operation, which is this one, and also p is squared. So we have to eliminate every single one of those in order to have p to be the subject of the formula. So accompanying p, we have s43 square root and the square that is accompanying p, all of which we have to eliminate. We have to eliminate them in order that p may be all by itself on one side of the equation. We need to eliminate the one that is least related to that p first. The square root is the least related to p, and we will eliminate it first. To eliminate that square root, we need to apply the operation that is opposite to square root. That operation is square. Because we are working with an equation, in order to keep it balanced, whatever we do to one side, we need to do it to the other side also. In our first step, of course, we will eliminate the one that is least related to the proposed subject. So let us therefore square both sides of the equation. We really intend to eliminate the one that is least related to this p in order to make p the subject of the formula. The square root operation is the one that is least related to p. We will therefore eliminate that square root first. How do we eliminate square root? We will have to apply something that will completely counteract that square root sign. And the exact opposite of square root is the square operation. Therefore, for everything that we have the square root of on that right hand side, we will have to take the square of that. Therefore, we need to square everything that is affected by the square root sign. And we need to do the same to the other side in order that the equation may remain balanced. So there we have squared the entire right hand side. As a matter of fact, the entire right hand side is affected by the square root sign. Therefore, we find the square, or take the square, which is the opposite of square root, which will eliminate the square root. But we cannot do that to one side. Whatever we do to one side, we will have to do that to the other side also. So we have to square that left hand side also. The brackets are necessary on that right hand side in order to demonstrate that it is the entire expression that is squared. On the left hand side, we are just squaring that single symbol r, and therefore no bracket is necessary. So it is necessary to demonstrate that we are finding the square, or taking the square of everything on the right hand side. Therefore, we need to throw everything on that right hand side in such a way that we may demonstrate that it is affected by the square operation, and that is why the bracket is necessary. On that left hand side, only the r that we have right there, and we may just square r. We do not have to include any bracket. So there we have the new expression with the square root eliminated from that right hand side, but we retain the square on the left hand side because we did not have anything acting as an inverse operation of that square. We squared the left hand side as a result of having to keep the equation balanced. The square root is eliminated from the right hand side, and on the left hand side we have r squared. And of course, we are demonstrating now that what we are explaining using this red bar is the step or the intermediate step between this expression and this one. So we are actually showing how we actually moved from here to here, which is not something that you really need to do in the examination. You will not get any more marks by doing it. But for the intent of giving a good demonstration and a good explanation, I am also in these tutorials including the intermediate steps. The one that is now least related to that P is the denominator S. I call eliminating denominators flattening the equation. A denominator is a number or expression that we divide by. The opposite of division is multiplication. We therefore need to multiply by S in order to eliminate S from that right hand side. And to keep the equation balanced, we need to do the same to the other side. So the next, well, we have eliminated the square root already, and we should take the same approach again. What do we have there that is least related to the proposed subject? The answer is S. We therefore eliminate S at this stage. And it is a denominator, something that we are dividing by. In order to eliminate this denominator, we will multiply by S, which is the same exact thing that is in the denominator. So we will eliminate that denominator by multiplying by S. And we need to do the same on the other side in order to keep the equation balanced. And notice that in this particular case also we are including brackets because we are demonstrating that it is the entire expression on the right hand side that we are multiplying by S, thereby eliminating the denominator on the right hand side, and we need to keep that equation balanced by multiplying by S on the left hand side also. So S is eliminated from the right hand side, and on the left hand side we have R squared S. So we have R squared S, and these are eliminated, and all that we have in the numerator will go back on that right hand side. Now we have 4 that is in an addition relationship with the term that contains P. 4 is in an addition relationship with the term that contains P. The addition sign that is between them is pertaining to the 3P squared. So this addition sign does not mean that we are adding 4. It means that we have 4 and added to 4 is 3P squared. So we are making that clear. I'm making it clear because in the future we may have a negative sign there, and we have to make it clear that the sign that we have here is pertaining to this. But what about the sign of the 4? Because it is in an addition relationship. What about that sign? The addition sign that is between them is pertaining to 3P squared. But 4 not preceded by any sign, its sign is also addition, which is the default sign. So addition sign is the default sign. If we have a number and it does not have a sign, we know that the number is positive. So it is on that premise that we are saying that the sign of 4 is a plus sign. The opposite of addition is subtraction. To eliminate 4, we need to subtract 4 from the right hand side, and to keep the equation balanced, we need to do the same to the left hand side. So let us subtract 4 from that right hand side, but we also need to subtract 4 from that left hand side. There we have it. So because of that, 4 minus 4, 4 will be eliminated from that right hand side, and on the left hand side we have r squared s minus 4. So 4 is eliminated from the right hand side, and on the left hand side we have r squared s minus 4. R squared s minus 4 and no 4 there. What do we do next? Right there is the most appropriate time to reverse the equation, placing the proposed subject on the left hand side, but we did not do it until the end. Notice that on the script we did not do it until the final answer is to be written. But usually a very good time in the solution of an equation that we could reverse the equation is always when the equation is flat. That is, we do not have denominators. So in an examination one might want to do that. However, others might say just solve the problem and reverse it in the end. Neither will receive any less mark in the examination, and it is up to the choice of the candidate. So there we have reversed the equation, writing 3p squared, on the left hand side. We are just taking the proposed subject to the left hand side at this stage, because it will eventually be written there. And of course we have r squared s minus 4. And one great problem, or one great question that students ask all the time when we reverse an equation and we do not change the signs: why don't we change the signs? The fact is, if p is equal to 6, then 6 is equal to p. If a is equal to b, then b is equal to a. And that is just a matter of simple common sense. Therefore, we do not have to change the signs if all that we are doing is reversing the equation. 3 is the coefficient of p squared, as we have it right here, and we are aiming at eliminating everything except that p, making p the subject of the formula. We have that coefficient of 3 accompanying p squared. That coefficient is a number that multiplies p. We will therefore do the opposite of multiplying by 3. And the opposite of multiplying by 3 is dividing by 3. So we will actually divide by 3 on the left hand side, and in order to keep the equation balanced, we will divide by 3 on the right hand side also. By so doing, 3 will be eliminated from that left hand side, and on the right hand side we have a new denominator of 3. So these are gone, and no doubt we have this expression right here, returning exactly as it is. We will finish up by eliminating the square. This we will do by taking the square root of both sides. We will eliminate the square on the left hand side by taking the opposite of square, and the opposite of square is square root. we will keep the equation balanced by applying it on both sides. So taking the square root of both sides, and the square root that we have on that left hand side is as a result of doing the opposite of square in order to eliminate that square operation. Therefore, on that left hand side we will have p, because the square and the square root being opposite or inverses of each other will eliminate each other, but the square root still stands on the right hand side. Square and square root being opposite operations will eliminate each other from that left hand side, and on the right hand side we have the square root of the entire expression. And we are about to make, what are we about to make the subject of the formula in this particular case? R the subject of the formula. We are attempting to make R the subject of the formula. R therefore needs to be all by itself on one side, preferably the left hand side of the equation. The letters and symbols that are in the way of R are pi, R, 2, and the square root, and the square operation. So we have here, in making this uppercase R the subject, we need to eliminate the lowercase r. We need also to eliminate 2, pi, and the square operation. As usual, begin by eliminating the one that is least related to r. And the one that is least related to r in this particular case is pi. So, pi in this particular case, that is the one that we will eliminate first. And notice that pi precedes the brackets in which we have the proposed subject enclosed. Without any arithmetic operator separating them, the assumed operation is multiplication. So we have pi preceding this pair of brackets, and no arithmetic operator is separating them. So the operation that we assume is multiplication. Multiplication is the assumed or the default operation. We therefore eliminate pi by making use of the opposite of multiplication, because it is related by multiplication. So we use the opposite of multiplication. So let us divide by pi on both sides. Dividing by pi will eliminate pi on the right hand side, and on the left hand side we have a. Divide by pi. Let's see what that tells us. We divide by pi on both sides. What happens? These will eliminate each other. Anything divided by itself is 1, and 1 times something is that same thing. So we have a over pi, and the rest we will have, with the exception of the pi, on that right hand side. What do? We say the same thing after every step. We will eliminate the one that is least related to the proposed subject first. Of course, we would have forgotten the one that we have eliminated already, and we are looking at the one that we have right there, and we say, which one is least related to the proposed subject? Well, I'm saying the square operation. That is the one. The one that is least related to the proposed subject, which is r, is now the square operation, which we will eliminate by taking the square root. we will take the square root of the other side also. Take the square root of both sides as usual in order to eliminate the square from that right hand side. The square from the right hand side is gone away with the square root operation, which is its inverse and the one that will eliminate it all together. And then we will have the square root on that left hand side. At the appropriate time, we may eliminate a denominator. We should not hesitate to do so. At the appropriate time that we may eliminate a denominator, we should not hesitate to do so. We eliminate a denominator by making use of multiplication. Why? Because a denominator is something that we divide by. So multiply the right hand side by 2 will cause the denominator to be eliminated. We, however, need to keep the equation balanced, and we will therefore multiply by 2 on the left hand side also. So multiply both sides by 2, eliminating 2 from this side, and then we will have 2 multiplying on that left hand side. 2 is eliminated from the denominator of the right hand side, and the left hand side is multiplied by 2. So these two will eliminate each other, and let's see what happens. So all that we have on that right hand side accompanying the proposed subject of the formula, which is the uppercase R, is that lowercase r. And how is that lowercase r related to that proposed subject? It is related by subtraction, and we will do the opposite of subtraction. So all that we have is that other single term, the lowercase r, that is subtracted from the proposed subject, the uppercase R. The opposite of subtraction is addition. R will be eliminated from the right hand side by adding R, and to keep the equation balanced, we add R to the left hand side also. So add R to both sides. We really intend to eliminate it from here, but we cannot just add R to that right hand side. It is an equation. If we do not balance the equation, then everything will be out of whack. Therefore, we need to add R to the left hand side also. So that will cause the lowercase r to be eliminated. After eliminating R, the equation is reversed, causing the proposed subject to be appropriately written on the left hand side. So there we have our equation with this R eliminated from that side, and all we need to do, as we have our bar telling that we are right here, how do we move from here to here? All we do is reverse the equation, and that's all there is to it. There we have highlighted the lowercase r and the uppercase r. Irrespective of the branch of algebra, as a matter of fact, irrespective of the branch of mathematics, different cases of the same letter are treated as two completely different symbols and cannot be used interchangeably. Therefore, if a problem has the lowercase r and we write the uppercase r, then we are taking an incorrect step. Those two symbols are as different as x and y for the purpose of algebra. So if we are talking about algebra, those two symbols being different cases of the same letter are to every degree different as it pertains to mathematics in general and algebra in particular. Therefore, they cannot be used interchangeably. We have to make a clear distinction between them. Also, it is good manners to write the subject on the left-hand side on completion of a transposition problem. So if we transpose, it is always good manners to put the proposed subject when we are through on the left-hand side, like so. I am hoping that the 2 that we have right there is not misinterpreted as a number that specifies the root. We really mean square root, but to include 2 as a part of the symbol would be a redundancy. As for square root, we already understand that the root is 2. It therefore should mean nothing else except that we are multiplying by 2. Besides, that was already discussed in the transposition problem. So we already discussed in the transposition problem that we are actually multiplying by 2. Therefore, we should have no confusion right there. Therefore, we do not have to be misled by the way that the expression is presented by a mathematical program, especially not in this particular case. So we do not have to be misled in this particular case because of how an expression is written by a mathematical program. So I'm sure that we did not, or I'm just making sure that someone does not misinterpret this 2 to mean that we are taking the square root. Now let us take a look at this problem. Notice that the intermediate steps are not there, and we have just discussed the intermediate steps. But let us take a look at the problem. When I am doing an examination and my students are taught this way also, they are taught to understand each step that I am taking. But intermediate steps are not completely necessary. You do not get extra marks for them. It is understood that by moving from here to here, we have pi that is being multiplied on the right hand side. This pi that we have here is the one that we know to be least related to the proposed subject, and we eliminate it first. We are eliminating by division. So we divide this side by pi and we divide the left hand side by pi. The pi will therefore be eliminated from the left hand side, and on the right hand side we have a over pi. Also, we need to eliminate again the one that is least related to the proposed subject on that right hand side. And in this particular case, after having eliminated pi already, the one that is least related is the square operation. To eliminate this square, we have to do the opposite of square, which is taking the square root. But we cannot do that to one side alone. We need to keep the equation balanced. So we take the square root of this side and take the square root of the other side also. So the square will be eliminated by the square root on the right hand side, and we have this notable square root on the left hand side. Why? Because we had to find the square root of both sides in order to keep the equation balanced. Then we come all the way down here now, and how did we get here? Realizing this denominator of 2, we need to eliminate that by multiplication. A denominator is something that we are dividing by. The opposite of division is multiplication. So we multiply by 2, and we will multiply by the 2 on the left hand side also. So in this particular case, the 2 will be eliminated from the right hand side, and we have a representation of the 2 multiplying on the left hand side. And that is the kind of process that we continue to do each time. So we assume that to go from here to here, we are adding r to both sides. So the r is eliminated from this side, and on the other side we have a positive r. We have r being added. And that is the understanding for each of those steps. And that is the understanding that the students should have. Well, all of these steps that we have there, although the intermediate step is not there, these steps are enough to demonstrate knowledge and understanding of the transposition process. And that is all that is required in mathematics. In this particular case, we are attempting to make n the subject of the formula, and we have a denominator that is ready for elimination. We will therefore go straight ahead and eliminate that denominator by multiplying by n, and we will do that on the other side also. What do we mean when we say we have this denominator ready to be eliminated? Two things. In the case that we can eliminate a denominator immediately when we are transposing a formula, that is always a very good move to make. And I am not saying that it is the very best move. It is a very good move, not necessarily the best. But in any sphere, mathematics, poetry, athletics, I am sure that a very good performance or a very good move is always acceptable. So that is one. It is always a very good thing to eliminate a denominator early if we can do that. And you know the term that I give to that, flattening the equation. Also, we realize that the proposed subject that we have right here is also the one that we have right here. But let us say that we were blind to the fact that the n is also the proposed subject. Then we realize that this n that we have right here would have been the least related, or whatever we have here would have been the least related to the proposed subject, and it is related by division. Therefore we would eliminate that by multiplication. But as I said before, eliminating a denominator is always a very good move. How do we eliminate denominators? We eliminate denominators by multiplying. A denominator is something that we divide by. Therefore, in order to eliminate that, we will multiply. So there we are, multiplying by n on both sides. Here, the n's will eliminate each other, and we have m n on the left hand side. We have one occurrence of n in the clear on the left hand side, but we have another concealed by the square root sign. We therefore need to eliminate that square root by squaring. We also need to square the other side. So we have this one that we have right here, an easy term, mn. We are saying that this one is in the clear, and we are saying that the other one is concealed by the square root sign. Therefore we need to eliminate that square root operation, and the opposite of square root is square. We will therefore square the right hand side in eliminating the square root, but keep the equation balanced by squaring the left hand side also. Here we will square both sides of the equation eliminating the square root from the right hand side, and the expression on the left hand side will be squared. So there we have it. And why didn't we, since we have mn, an entire expression, not a single letter or symbol or number, why did we square m and square n? Apart from the fact that squaring m and squaring n is exactly equivalent to, or we'll say exactly the same in value as squaring the entire thing, then we'll take a look at the other reason for taking them separately. So we square the left hand side as a result of attempting to eliminate that square root from that right hand side. And also I am saying that n squared is equal to mn all squared. So there we have eliminated from that right hand side the square root. And what do we need to do now? Well, our analysis tells us that we have n on one side and n on the other side, and we are attempting to make n the subject of the formula. Therefore, what do? Now we have two occurrences of the proposed subject, one on either side of the equation. It is bad to have them, well, two occurrences of the proposed subject, but worse that we have them on either side of the equation. We need to have them on the same side and everything else on the other side. We may choose any side, preferably the left hand side, for obvious reason, because when we write the subject we want to have that on the left hand side. But it is not a matter of having them, the occurrences of the proposed subject on the left hand side alone, why we are choosing to do that. But we are saying this for obvious reason. However, the decision is usually heavily driven by signs that will be the result of the rearrangement. It is desirable to have as few negative signs as possible, and we may not look at that at the end of this solution, but definitely before the end of these transposition tutorials we'll take a look at what we mean when we say as few negative signs as possible. So let us take the necessary step. Transpose n squared from right to left by adding it on both sides. N squared will be eliminated from the right hand side, and n squared will be added to the expression that is on the left hand side. So that negative n squared will be eliminated by adding n squared. And on the left hand side we have an additional term, n squared. So here we have an expression of it with the n squared eliminated, and on the left hand side we have this additional term, n squared. Now we have two occurrences of the proposed subject, and we have them right in this expression right here, and we move from here to here, and I am sure that it is not difficult, much more impossible, because all we are doing is taking a common factor of that proposed subject. Now we have two occurrences of the proposed subject n on the left hand side. In order to make it the subject, we need only one. That transition may be realized by factorization. We will therefore take out a common factor of n squared. Take out a common factor of n squared, and we will see in a more graphic way the factorization process when we take a look at the second tutorial. So we will not go through all of the details in this tutorial, but in the very next one we will include as many instances as possible when we imagine that more details need to be added. So we have two occurrences of the proposed subject and we need only one. And we are saying that that transition may be realized by factorization. We will therefore take out a common factor of n squared. Now that we have the common factor of n squared, it is being multiplied by the other factor, and we call the other factor the large factor. So it is not like large in terms of its value, but because it's a little bit more cumbersome than the other one, which contains the proposed subject, then we refer to it as the quote-unquote large factor, and that we will see also in the second tutorial. So we have taken out a common factor of n squared, which goes here, and in this term the n squared is gone, so we have the m squared going back, and also n squared into n squared is 1, which is a process that we use in factorization, taking the common factor and dividing each of the terms by the common factor, that we will see in another tutorial. So the large factor is m squared plus 1, and we will eliminate that large factor by division, and we'll do that on the next slide. So there we have it. What do we do? Well, this m squared preceding these, this single expression that is inside of the bracket means that we are actually multiplying. They are in a multiplication relationship. Therefore, to eliminate that large factor, we will divide. So let us divide. Divide by the large factor of m squared plus 1. So there we have it. Dividing by the large factor m squared plus 1, zip, zap, will be eliminated from that left hand side, and on the right hand side we will have 1 over m squared plus 1. There we have it. What do we do from henceforth? We are sure that by now we should have learned a single thing, that the opposite of square root is square, and the opposite of square is square root. So the opposite of large is small. The opposite of small is large. Now that we need to eliminate the square here, we need to apply the opposite or the inverse operation, which is square root. So what do we do? As I said before, now that the only thing that remains is n squared, we will finish up by eliminating the square by taking its opposite, which is the square root. We will therefore take the square root of both sides. And what will happen? The square will be eliminated from the left hand side, and on the right hand side we have the square root of all of 1 over all of n squared plus 1. And of course we have it written like this and like this, and we are saying both are equal. Well, if one can be written as the other, or we have a single answer written in two forms, it means that those two forms should be equal. The expression on the left is the one that we have written for the answer. It may be written as the one on the right because of two things. One, the square root of the quotient is the quotient of the square root. So there we have it. We are saying that if we are taking the square root of all of this, it is equal to taking the square root of the numerator and taking the square root of the denominator. That's for 1. For 2, the square root of 1 is equal to 1. So we have it right there. Also, earlier we made use of the fact that mn all squared is equal to m squared n squared when squaring the left hand side. We choose the second expression because it facilitates the separation of n squared from the rest of the expression, which is a sensible move for making n the subject of the formula. So instead of doing this on the left hand side, we did this. As a matter of fact, they are equal. But why did we choose this? Because separating them instead of taking them together facilitates making n the subject of the formula. Now we are taking a look at problem number 4. In solving problem number 4, we may take any of a number of approaches. The two that are foremost in my mind are 1. So the first one of the two that we have, well, I have foremost in my mind is eliminate the denominators in the first step. Flattening the equation, as it is called, is always a very good move to make. This will be followed by accumulating the terms that contain the proposed subject on one side. So that is what we do first. Eliminate the denominators altogether and then accumulate the terms that have the proposed subject on one side. They should already be on the same side. The expression will then be factorized in order to arrive at a single occurrence, and we will finish up by dividing by the other factor, the one that we call the large factor. So we would have two occurrences of the proposed subject, take them to one side like we have done before, like this. Two occurrences of the n squared, take them to the same side, factorize, and then divide by the large factor, which is a standard thing for transposition. That is one. But we have another one. Let's see what that is saying to us. Make use of the fact that if two fractions are equal and we invert them, then they are still equal. But we have 3 fractions. So we have 1, 2, 3 fractions. But I am saying we could have made use of the fact that, which is the one that we are about to use, that if 2 fractions are equal and we invert them, then the results of inverting both of them are still equal. So we could make use of that. But we have 3 fractions, not 2. The ones that do not contain the proposed subject will be accumulated on one side and be made into a single fraction then. And then we'll be able to find the reciprocal. As a matter of fact, I am imagining that the CSEC examiners are testing our ability with that, because by giving us like this, as a matter of fact, I see candidates doing it, inverting all of the fractions and continuing to transpose the formula. But the fact is, we cannot do that so easily with 3 fractions and be correct. Therefore, we need to convert to 2 fractions that are on opposite sides of the equal sign, and then we may do our inversion. So the ones that do not contain the proposed subject will be accumulated on one side and be made into a single fraction. So let us do that in our first step. We will proceed to eliminate 1 over v from the right hand side. It is in an addition relationship with the term that contains the proposed subject. We will therefore subtract 1 over v from that right hand side and keep the equation balanced by doing the same on the other side, which is the left hand side. So we are eliminating the term. So we have t is the proposed subject. We need to eliminate this 1 over v. So we subtract 1 over v from the right hand side, and we need to do the same on the left hand side. So there we have the 1 over v eliminated from the right hand side, and we have on the left hand side this negative 1 over v. What do we do now? T is the proposed subject, and it is in the denominator of the fraction. We may therefore take an approach in which we find the reciprocal of the fraction 2 over t. That will cause t to be in the numerator, which is exactly where we want it. The principle to apply is that if two fractions are equal and we reciprocate them, then the two resulting fractions will still be equal. Before reciprocating the fractions, we have to ensure that there are 2 of them, 1 on either side of the equation. There are 2 of them on the left hand side alone and 1 on the right. We therefore have to write the left hand side as a single fraction. We will use the method that was discussed in the tutorials on fractions, your favorite. What's that? That will be the new denominator. We have v and we subtract r. And of course that sum of the fractions that we have on this side is equal to 2 over t. What do we do then? We may now write the reciprocal of the 2 fractions. So after having only 2 fractions, 1 on either side, then we may go straight ahead and do the reciprocal of both of them. That will still be equal. But not before we have converted the 2 fractions on the left hand side into 1. So we would have to do that first before we can reciprocate. Only we have right here this 2 on the right hand side is preventing us from making t the subject of the formula. It is in the denominator of the fraction. We are therefore dividing t by 2. In order to eliminate 2, we need to multiply the right hand side by 2, and to keep the equation balanced, we need to multiply by 2 on the left hand side also. So eliminate this 2 that we are dividing by multiplying by 2. Keep the equation balanced by multiplying by 2 on the left hand side also. So there we have it, the elimination of the 2 from the right hand side, and the left hand side is multiplied by 2, and then let us finally reverse the equation in order to cause the proposed subject to become the subject.